Very good. Let's share the screen. Yes. Yes. Cool. Let me know if you cannot see the screen. Otherwise, I'm gonna keep going. So today we're gonna talk about this
Sorry, Nick.
paper. Yeah.
I do see the screen, but it's very blurry. Just click to exit full screen. Now I do see it.
1 second. Let's stop and do this, and then reshare. It's not possible. Okay, 1 second. The same thing will happen, but let's see. Blurry?
Yeah, it's the same thing. It just says
Yeah.
click text full screen and blur.
I can see the blur. Add windows. This window. Okay.
Yes,
That's
that's
good.
better.
Thanks.
Thank you.
Cool. Cool. So we're going to talk about this paper that was published a few days ago that was trying to find some way to track AI progress that doesn't become obsolete in a few months, and that is intuitive to communicate to other people. So essentially, the motivation behind that paper was, as you probably have seen, like you name the benchmark. It only, a benchmark is announced, and then it used to be a few years. Now it's a few, then it became a few months. Now it's a few days, weeks or days. Increasing, essentially, like it only takes a few, like a limited amount of time between when a benchmark is released and when AI is able to outperform humans on that benchmark, which makes tracking progress on AI. Even though intuitively we get a sense that AI is getting better and these benchmarks are harder and harder, it just makes it a little bit harder to track progress over a long period of time. So that's the motivation. It was saying, by the way, that some of these benchmarks, like you might say, okay, maybe we can use the latest benchmarks to track very old models, but like for example, in this math benchmark, most models before the time that it was introduced, they would do 0 basically on this benchmark. So that wouldn't work either. Anyway, so they propose to track progress with this sort of task completion time horizon metric. And it's kind of an intuitive way to think about it, even though it's a little bit, it's not like a one word to explain, but they're trying to capture how much time it takes a human to do a task. And then, so that's, one thing. So if it takes someone a minute to do a task versus an hour, we're talking about a completely different complexity and AI ability if the AI can do that task. And then the 50% task completion on that means that AI is able to do the task, X amount of time, 50% of the time, essentially. So that's the metric. I mean, it kind of makes sense. I mean, of course, again, you might argue sometimes with AI, things that are hard for humans are easy for AI and the other way around. So, like they might have found, weird results, but it ended up not to be the case. It ended up to work nicely as well as intuitively as a metric. So how did they do it? I have to say it's quite of a limited study to begin with. So they focused on software engineering tasks as usual, even though they did try to test a little bit outside of the boundaries of the study, but nevertheless, it was software engineering mainly, with the limitations that that implies. They took 3 different benchmarks. I think 2 of them they have created themselves. But in any case, they consisted of tasks of varying difficulty. By difficulty, we mean the time it takes for humans to do the task. They evaluated how much time it takes. I mean, they've done that anyway for some of these benchmarks, but for those that they haven't, they evaluated it. They assigned the task to a human and measured the time it takes them to do it, and then they did the same for the model, so that they can create that sort of time horizon. Like how successful is a model for a given time horizon, essentially. And interestingly, also to be able to calculate, how this time horizon changes over time. Like if AI is able to do 1 minute tasks with 50% success rate today, like when will it able to do 2 minute tasks, and so on and so forth. So this is their methodology. Just to give you a little bit of an idea of the data they use, like super simple tasks such as, what file is a shell script from, like the name of the file, all the way to optimizing CUDA kernel. So having to write code and have it perform better, significantly better than what exists. Cool. So in terms of measurements, they use, we did say they use humans and models. So they used well-educated people, everyone had finished good universities. They also had relevant experience, which is important. It wasn't sort of, crowds, like, or junior experience. They did have relevant experience on the tasks of at least 5 years. They did have humans do the task most of the time, but it's worth saying that in a very few cases, they did just estimate the task. It would take that amount of time. Model-wise, they ran more than once per task. They didn't use any complicated prompting, just to even the field, but it also means, of course, that models could perform probably a little bit better than like what they're reporting. But I think that's only a good thing for what we care about, to have some sort of floor evaluation of a minimum performance. The models had access to Python and Bash, but not access to the internet or complicated tools. It's also worth saying they didn't use any inference time scaling very much, which also gives, other than, of course, the one that the models use by themselves. So they did test, O1, for example, that takes time to respond, but they didn't force it to rethink or think longer and things like that. Anyway, this is how they measured, and let's see some results they got. So this would be, by the way, a view that we had until now, that they're also including. Essentially, what would be the success rate for different AI models on this benchmark? Of course, at the current time, the tasks that are in this benchmark are until difficulty level of, let's say, maybe 8 hours or something. So this benchmark will be solved at some point, and it again demonstrates the issue with the previous way of thinking about AI. Like at some point, this benchmark will become obsolete. Of course, you can add more difficult tasks and extend it, but anyhow. So what I try to do is sort of create these time horizons per model, which all look very similar. Essentially, for a given complexity, like tasks that take humans 1 second for, and so on and so forth. As you might expect, the success rate drops as the time horizon increases, or you might say, the task complexity increases, and it kind of falls in a similar way. So that's nice and clean. And if you see the red dotted line, of course, hits the time horizon slightly different per model. So for example, GPT-4o, it hits around 4 to 15 minutes, let's say 10. But for Claude 3.7, it hits on an hour, meaning that, like it's a better model. It can solve more complex tasks. But anyway, this is for different models, not super helpful to, interpret just from looking at all these graphs. But what's probably the most intuitive graph is this one, which essentially plots the different model releases against the time horizon. So you can clearly see the progress that AI has been making on a time basis, per year. And there are two lines here that are worth highlighting. One is the 80% success rate instead of the 50 that they suggested, which I actually can prefer because, for our purposes, we're an AI consultants. We want to be helping clients achieve things. And, on the 50% success rate, even though it does communicate progress, it kind of works a little bit flakily, whereas with the 80% success rate, it's something that clients can use. But in any case, both lines seem to follow the same trend, which is the thing to keep in mind. So irrespective of whether you use 80, 50, or other percentage of success rate, how often AI can succeed in the task, the rate of progress is similar. It's just that, of course, given the success rate, it might mean that we're in a different time horizon. So for the 80%, for example, if we assume this is a little bit of an outlier at the start of the year, if we say we're here, then we would be in around 8 minutes. And maybe by the end of the year, we would be around, close to 30. So this is for the 80%. And it's also worth noting that it takes around a year to go from the 50 to the 80%. So 50% is already on 30 minutes with the 80% success rate. All of which is to say, I think the 50% success rate, in my opinion, you can view as we're seeing like something happening in the AI field that is kind of working. Maybe a lot of people are sort of saying, okay, this doesn't work very well in conferences and things like that. And then you wait for a year and it works quite well. Is one way to look at it. The other interesting thing is that the doubling time, how much time it takes to go from the 2 minutes to 4 minutes and so on and so forth, is about 6 months. It's a little bit longer, but, just to remember easier, maybe it's worth, they also say in the paper, we can say it's a little bit about 6 months, even though it's closer to 7 here. They're not super exact estimates, but it's worth saying that the regression that is fitted here fits the data quite nicely, and they've done some experiments on different sort of fits, which were less fitted to the data. So I'd say for this data point we're seeing here, like the line is quite well fitted into the 7-month mark. But if it helps you remember it better, you can say that it doubles twice within a year. Anyway, the other thing they did in the paper, which is interesting, I haven't followed very closely what is the y-axis here, but essentially there are different ways to estimate when AI will reach the 1 month time horizon, which they kind of think as kind of like a milestone in AI. Like if it can do a month of work, then it can probably do most things or, be super valuable kind of thing. So that's why I say AGI by 2030. And a lot of those estimates, like it can be as early as 2027, as you might have heard, no surprises there, but a lot of estimates sort of seem to converge towards the, by end of the decade, you can, remember it. So that's the other thing. And last thing on the results is they did also estimate the cost of doing those tasks currently for the AI versus the human. They calculated the human cost by normalizing a Google salary of an L4 engineer. This is around $1,000 a day, like $140 an hour, they're saying. In any case, like irrespective of what it is, all of what this is showing essentially is that it costs a little bit less. So anything you see below this line is a cost ratio below 1, like it costs less for an AI to do it. Anyway, all of which might make people a little bit worried about certain things, but I wouldn't interpret it exactly like that. Anyway, let's look at some ablations before we look at some takeaway points. So when if you remember from this graph, the first model here is GPT-3 essentially. So they wanted to see, okay, does this hold if we go a little bit further back? To do that, they had to create some task that took artificially, like it was super simple, like a 2-second task kind of thing, which they did. And then they added GPT-2, all of which is to say that the line doesn't change very much. Like it seems that it follows the progress that AI is sort of going, even if you're trying to go earlier in the AI development. So that's one thing they tested against. The other and more interesting thing is, because one of the pushbacks I had for the paper was that it might take an hour for a human to do something, but they might be doing some sort of repetitive work, like they might be doing the same thing, but like it only you can only do so many things. Like if you're copying and pasting items from an Excel sheet, it might take you an hour to do it for a lot of rows, but it's not very complicated. They did try to test for something like that with a score they introduced called messiness, like how difficult the task was, or the best way to say it is how open-ended the task was, like with more open-ended tasks being a little bit more difficult than, of course, very well-defined tasks. Not exactly the pushback I had, but it controls a little bit for the fact that, the time horizon is not, a super, accurate necessarily proxy of complexity. In any case, what they found was that, of course, more messy tasks, less well-defined models struggle a little bit more with. So these are, like on the bottom, than very well-defined tasks. But the more important thing here is that the trend, even though not super clear here, but kind of clear, is the same. So the trend seems to be very similar, like on how on the progress first of all, and how much time it takes to double, like to become better. So even though intuitively, yes, it makes sense, more messy tasks, more open-ended are more difficult. You might argue maybe AI cannot solve those tasks, but if the rate of progress is the same, then that doesn't hold either, because it's just going to take a little bit more time to resolve even those tasks, probably. And last thing to say is the deep task on the ablations, 5 pull requests they had internally. So this is a very real task. They had 5 open issues essentially that they wanted to resolve. Now, of course, they didn't have a lot of success on those pull requests, so they don't very much report on them. But so they did, the AI didn't manage to solve everything that you see with 0. Essentially, it managed to solve 2 things. But if you actually look at the time it took the humans to resolve them, so if we forget a bit the baseliner time, the maintainer time, so 5 minutes for the 2 that it solved versus 20 and 230, you kind of see at least that it probably makes sense that it didn't solve it, because the 5-minute mark were definitely, where AI can solve things, but, like the 20 and definitely the, 230 minutes task, AI is not there yet. So in some ways it goes towards the same narrative, even though, like there's a very limited test they did. Anyway, some takeaways on my side. I think this metric is intuitive, so this is like really nice, and we can communicate it externally with clients. It kind of makes sense. Of course, I think, unlike the narrative that AI is going to take our job in 2030, that as AI is sort of taking away tasks that take an hour or what have you, of course we're going to be doing other tasks. Same way that it used to take me an hour or 2 to create a piece of content. and maybe now it takes me 10 or 20 minutes, but I do maybe I create more content or I do other things. So in some ways, as these tasks go away, we will have new tasks that will take X amount of time that AI will not be able to do immediately. So in some ways, I think even this way of looking at AI is a little bit has this limitation that like we might always be in a place where AI is doing tasks that take 10 minutes because the 10-minute tasks now is 1 second essentially. Anyway, so that's problem number one in my opinion. And but I think what's definitely useful is this rate of progress. So I mean, this is not like this is crude thoughts, but if you think meaningful tasks might be something that takes 30 minutes to 4 hours, like some sort of software engineering task that you and if this holds for other tasks, not only software engineering, then you might argue that okay, how much time will it take AI to take a 4-hour task or a 30-minute task and basically collapse it to a minute? Around 2 to 4 years, given the twice doubling time per year. Anyway, so I think this is a useful thing to think, this is a useful thing to keep in mind, because maybe this is how we're going to be seeing AI progressing. There's going to be a tool now, like an ID or something like in software engineering or a different tool that the professionals use that is going to be automating, help automate some of the tasks people do right now. But then they're going to be doing these other tasks that the tool allows them to do to spend time meaningfully. And then, like in a year or 4-year cycle of product development, these tasks will be automated, but new ones will emerge. Anyway, all of which is to say, I don't think any job will be going obsolete. I think probably this sort of loop might sort of happen where the AI progress is going to be encapsulated into, the product we use, and, every few years, essentially, some of the tasks we did 4 years ago, they're not going to be relevant anymore. Anyway. Dashin.
It's a super interesting paper. Thanks for presenting it. Before I say any more, I think Matt raised his hand before. Madam.
Yeah, thanks. It was interesting. Could you go back to the slide about the internal PRs, please? I had some questions about that.
Such which slide will be that? Which one?
It's like a couple of slides back about the internal PR completion.
Yeah.
That one. So I'm noticing issue 11 is also a 5-minute task, but the models didn't seem to be able to complete it. Do they go into at all why that might be?
Don't think so, but we can check. Models, issue 11, for example. Okay, so we not expect models. Okay, they do raise this other point that maintainers knew the code base quite well. So the maintainer took 5 minutes, but someone new to the project, it took a little bit more. So 93.
That's not much different to task 1, though.
Yeah, wait, Johan. I mean, that's
difference to that.
It's 10 more than 10 minutes more, This is the 10 minutes that AI can. I don't know.
It's not super convincing reasoning from them. What does it mean to get a partial score? Or
partial score is does say here. Wait.
It says that model solutions were manually scored.
This one. 0.75 there were needs, but the PR could be merged. 1 if it was merged at least.
Okay, interesting. All right, cheers.
I quite like the approach to measuring AI progress, but I think there are also two big caveats here. One is that this extrapolates pretty far into the future. It's an extrapolation. So looking at the slowdown in model progress with pre-training, and that apparently synthetic training didn't help that much with that either. Otherwise, we wouldn't have seen GPT 4.5 and Llama 4 falling behind expectations, kind of. I'm wondering how long or whether we will continue this exponential progress just with training time inference scaling.
Yeah.
So that's one question, or that's one point I think that is to be considered. The other one, it's maybe a bit academic, but on one of the first slides you showed that LLMs achieve superhuman performance in many tasks, and that is true. But I think that the pre-training on the test set is still an issue there. I mean, recently I saw another study. I tried to find it now. It wasn't quite a full paper, but it was someone posting results on math benchmark that they created, and even latest generation models failed with like I don't know 5 to 8% accuracy at best on those problems.
Yeah,
I do
that's
think
the math Olympiad in the US that they run the models against just a few.
I think so, yeah. And I think like the best performing models at like somewhere between 5 and 8%, and most models like GPT 3.5 or something like that had like 0%.
Yeah.
And that is way worse than it performed on other math benchmarks that were available before. So I don't know how much of this performance is due to just memorizing to some extent the training data. Then again, I think in many use cases it doesn't matter. I mean, if it works, right? So if the problem is common enough, so it's in a train set and it still is a problem you need to solve and the model can help you solve it, that's fine and it counts as progress for sure. But I think it's a caveat, especially once we move away from common problems that are probably available in a training set.
Yeah. I think in that benchmark with the math, they had to create proofs as well. The model had to create proofs, and they were saying that they've been trained with reinforcement learning to produce the right answer, but not necessarily to produce logical proofs, and that invalidates the answer straight away. But at the same time, you might say maybe they're not able to create proofs, and they only learn to sort of arrive at the solution magically for similarly looking problem. We'll see.
Yeah, I'm not saying it is the case 100%. I'm just saying it is certainly a case to some extent, and I don't know how that will translate into real world usability. But I mean, it's more generally a note on AI progress measurement. I think this paper generally does a good job in introducing this notion of measuring by task length.
Cool. Anything else?
It'd be interesting to see it on tasks that aren't software engineering, because software engineering is both quite easily verifiable, especially if they're using, say, agents, which I assume some of these are, and it has masses of training data from scraping GitHub and so on. But things like math, common sense reasoning, logic that AI does quite consistently struggle with, it'd be quite interesting to see if the same pattern holds for them.
Yeah. Yeah, I agree 100%. I think that's the main limitation here. Like software engineering, we've all seen successes in software engineering, which we want to see successes in other things as well. Good points.
I think it's an interesting concept. I'd be interested to see it extended, but right now it feels cherry-picked. I don't know how true that is, but that's very much the impression it gives me of, on this very specific task, for these models, for these PRs that we don't explain very well, look, the pattern holds. It'd be interesting to see reproducibility or something like that.
I don't think it's intentionally cherry-picked. It's just very easy to get data for software engineering problems.
Yeah.
There's that too.
At the same time, I think this is the same thing OpenAI did, right? Like they did this paper benchmark where they're trying to assess whether AI can do, again, software engineering tasks from Upwork. Yeah, at some point it would be good to see it complete other things as well.
Yeah.
Okay.
Probably to some extent, we're marketing this a lot at software engineers, and this is what they'll be interested in.
Exactly. Exactly. Nice.
But yeah, it'll be interesting to see how the pattern holds up.
Boom. I share the slides and I'll upload the recording. Okay.
Nice. Thanks, and thanks for presenting.
Thanks, Nick.
Vale.
All
Thanks,
right.
Nick.
See you guys.
See you soon.
Thank you, Nick.
See ya.
Bye.